Hey guys, welcome back to the TTA Performance YouTube channel. And like I had mentioned before, I was wanting to do a part 3 to the 81 Daytona 500 pace car that we have. And in part 2, we talked about all the electrical issues this car had, corrected a bunch of stuff, making a lot of the accessories work and everything. At the end of that video, I had mentioned that we were going to look into seeing what we could do about the computer control and trying to make it, how do we want to explain this? Basically make it so that we can kind of tune it without having to burn a chip for it. So let's go over a few things about the computer command control, and we'll take a look at this car here and I'll show you some things on it. So the computer command control is basically a really crude first generation ECM computer system, and basically they were trying to control some of the fuel metering in the carburetor using a computer. The other side of it is that the entire ignition timing advance is all controlled with the prom chip inside the ECM. So this distributor in this car has no vacuum advance. It has no weights and springs. It's completely locked out. It has a 7-pin ignition module in the distributor. Plus it also has the spark control box similar to the 1980 with the knock sensor and everything. Now this car, first off, the knock sensor and that ESC circuit has already been bypassed. I don't like using them. They're problematic between giving incorrect timing to not starting the car at all with no spark. So ignition timing is not a problem with this one. So we're going to take a look at the carburetor here. This carburetor, the part number is a 1708-1273, and we can see that we have a throttle position sensor on here, and then we have the mixture control solenoid up here. Now, the way this system works is that it's a feedback carburetor, so there has to be another sensor somewhere. The oxygen sensor, which that's the factory oxygen sensor. Notice it's in the up pipe, not in the down pipe. It's actually in the up pipe. This is a 2-wire oxygen sensor. The second wire, the black wire, is just a separate ground, just to give it make sure the signal is not trying to ground through the oxygen sensor, through the threads and the pipe and everything. It's got its own separate ground going to the back of the cylinder head. Now, thing about oxygen sensors is that they create their own voltage. Once they get up to a certain operating temperature, they start to put out a voltage. That voltage is dependent on how much oxygen is in the exhaust, not fuel. It's oxygen. So, just a quick reminder, if you have a misfire and one cylinder is not firing, you will actually show lean on the oxygen sensor. Most people don't understand that because they think, well, with a misfire, we have fuel going through the exhaust. Why isn't it showing rich? Because you didn't burn the oxygen in that cylinder. Yeah, you didn't burn the fuel, but you also didn't burn the oxygen. So if you didn't burn the oxygen, raw oxygen went, well, I shouldn't say raw oxygen, but basically atmospheric oxygen went through the exhaust and the oxygen sensor picked it up and said, hey, you're lean. So with that said, and that quick little rundown of how the oxygen sensor works, basically the oxygen sensor is going to put out a signal anywhere from 1/10 of a volt, so 0.1 volts, all the way up to 1 volt. The lower the voltage, the leaner the mixture. The higher the voltage, the richer the mixture, or less oxygen. So with that said, the ECM is reading that. That is an input to the ECM. ECM says, hey, I see that you're got this amount of voltage. It's showing that you're either rich or lean, and then it'll go and it'll change that solenoid, which is got a duty cycle to it, so it's cycled on and off somewhat quickly, and that's moving the metering rods in the jets of the carburetor and changing the fuel mixture while it's running. And what it's trying to maintain, based on the prom chip and what is burned into the tune file of the prom chip, is that it's trying to maintain what they would call a 14.7 to 1 air-fuel ratio. Now, 14.7, also known as stoichiometric ratio, which is what is required, the air-fuel ratio required, 14.7 parts of air to 1 part of fuel, the air-fuel ratio required to get a complete burn of gasoline. That's what that stands for. And so the ECM is trying to maintain that 14.7 1 air-fuel ratio by cycling that mixture control solenoid. If it leaves that solenoid on, it'll actually energize the solenoid and push a little plunger to lean out the carburetor by putting the metering rods down into the jets further, restricting fuel. If it says, hey, we need to richen up, it'll turn off the mixture control solenoid, or not pulse it and hold it on as long, and allow the springs to push the metering rods up and richen the fuel mixture. And it keeps cycling that. Now, these are not very fast computers, so it's a little lazy. But the thing is that what I notice is these cars sometimes, especially if there's been a rebuild and the camshaft's a little bit bigger than stock, or just in general, sometimes the ethanol blended fuels, 10% ethanol and whatnot, want to run a little bit richer. And usually these cars will run better if they're richened up a little bit. The 14.7 to 1 air-fuel ratio, it's a little bit on the lean side for today's fuel and everything. And I've noticed that the cars run better if they're just richened up a little bit. So I tried to adjust the lean stop inside the carburetor. You really can't get it to run much richer. So what we're going to show here is I've got a wideband oxygen sensor in the downpipe, which is under the car. I got it welded into the exhaust under the car. And we're going to see what this ECM is doing and what kind of air-fuel mixture it is producing out of the exhaust. So we'll get it fired up here, and we'll get the wideband oxygen sensor, which right now is showing 15, and well, it's because it was just running, so there's some exhaust residual just kind of stagnant in the exhaust. Okay, so we got the engine warming up, or pretty much warmed up. I put this little tool. This is an adjustment tool for the air bleed that sits behind here. I left it in the car. You can see the mixture control solenoid is bouncing up and down. This rests on the plunger. So this is actually giving a visual of how fast the computer is cycling that solenoid and making that plunger go up and down, trying to control the metering rod. And right now, you can see it's idling pretty lean. 15. It's trying to hover around that 14.7, and it'll purposely swing rich to lean to make sure that the oxygen sensor is working. But you can see it's not doing too bad of a job, that, trying to stay at that 14.7. A little touch on the lean side. But to me, this is actually pretty lean, because if I actually come in here and I'll close this choke plate partially and richen the mixture, the car will actually run a little bit better. Put my hand over it actually. Oop. Bumped the... If I can get this like around 14.0, let me pull out this. The funny part is if you bump this and hold it down, you'll lean it out to the point that the engine runs rough. The thing is that solenoid is on a spring and the metering rods are on springs, that if you were to unplug the solenoid and take away the voltage, everything would go full rich. So actually we can do that. Here we are idling in that 14.7 range. If I come in here and disconnect this, okay, now she's unplugged. You see we gained some RPM, kind of smooth the engine out a little bit. We didn't change the throttle, so there's no additional air coming in. It's just we richened it up. Well, how rich did we make it by unplugging it? Pretty darn rich. 12.0. High 11s, 12.0. Now the computer's very confused because it's like, hey, we're really rich, and it's trying to lean it out, but it can't because there's no more, we took away the control. So we'll plug this back in. Taking this unplugged immediately sets the check engine light. As you can see, the check engine light's on. So we'll plug this back in. Everything's being controlled again. It went way lean because the computer was confused there for a second. It'll probably start coming back now that it sees that it's lean. There it goes. Trying to maintain 14.7. There, yep, now it's just going to float in that area. One of the things too I want to show is that if I throttle it up here, and just hold it at like 1,500, 2 grand. Same thing. Trying to maintain 14.7. And you can hear in the exhaust the up and down roller coaster of the engine speed, because when it goes rich, it picks up RPM, and when it goes lean, it brings down the RPM. So it's got like this surge to it. Now, if I were to richen that up, let's see if we rev it up. If I rev it up and close the choke at the same time, if I can do that. Here we are maintaining that RPM up. See, it's, if I just close the choke, runs so much better versus lean. That's the choke wide open. I didn't move. I'll hold the throttle steady, close the choke. Oh, look, it runs so much better. Well, it's a little rich there. I'll open up the choke. That'd be pretty good there. Open the choke wide open, and it just leans it right out and brings the RPM down. So what are we looking to do here? Well, let me shut the car off and I'll explain what I want to do. So what I want to do is fool the computer. And I want to fool the oxygen sensor. And how are we going to go about doing that? Let me show you a few things here. I'll turn the camera around. So right now I've got a few things hooked up. And one of the things that I purchased to use and to try here is a wideband oxygen sensor. Now I have a wideband that I use for tuning and testing and whatever, but it just reads an oxygen sensor. There's nothing else about it. So I went and looked around, and what I had found was this here. This is a pretty common this is a pretty common wideband oxygen sensor setup. Innovate Motorsports out of Illinois. This is their LC2 model, the LC2 wideband sensor. And why I went with this is there's an option for a narrow band output with this. So let me show you a little more of what's going on. So I got everything kind of just temporarily wired up here, and I'll go over everything here in a second. This is their little controller for their oxygen sensor. So they give you a wideband oxygen sensor, they give you this controller, and then some cabling. And this is programmable. And so what I have going on is the wideband oxygen sensor is actually in the downpipe of the exhaust under the car. And I've got it running up to the programmer right here. Well, if you have to purchase separately this USB adapter to go to a laptop. So what I have going on with the laptop here, this is the software for it. It's free to download. And basically it's a gauge on the laptop at this point. And what's interesting is that I can actually go in and do a programming feature, which I'll show you here. I have to actually turn, right now I'm logged or hooked up to it. I'm going to disable it. And we're going to come over here to what they call the LM programmer. And we're just going to, so this programmer here has analog 1 and analog 2. Analog 1 is if we want to hook it up to a wideband oxygen sensor gauge, 0 to 5 volts. That's one tab there, kind of gives you a scale which you can adjust. But then they have analog output 2. Analog output 2 is to simulate a narrow band oxygen sensor so that we can actually tell the factory computer, hey, let's use the wideband as the input to the factory ECM. So that's what I have going on right here. And I actually already tried to start rescaling it, because originally it was actually scaled, and there's different things you can do here. You can toggle between lambda and stoichiometric ratio, or 14.7 air fuel. You can go air fuel or lambda. I like to look in air fuel. I've already rescaled it so that the 14.7 to 1 air fuel ratio, that stoichiometric air fuel ratio, it takes place at 0.39 volts. Well, why did I do that? Because the factory computer thinks 14.7 is 0.45 volts. Well, if I give it a little bit leaner voltage as the 14.7 mark, the computer is going to say, hey, that 0.39 according to the factory ECM is a little too lean. I want to be at 450, richen up the fuel mixture to get 450. So when the computer richens up the mixture for this new wideband oxygen sensor to output 450, we're going to have a richer fuel mixture than 14.7, which is what I want. So let's see how this all works. We're going to test this first before we make any other changes. So I'll get back into, actually I got to turn this off. Get rid of that. We'll come back into my air fuel ratio. We'll set this up. Yes, connect. And it's warming up the oxygen sensor. I think the car's got to actually be running too. So let's start up the car here. Now, what I did here was that I have the output wire from my LC2 module. I have it hooked up to my voltmeter, and like I had showed before, I rescaled the analog output, like if I wanted to give it to the factory ECM. So right now, as you can see, at its richest point, it's not even making the 450 millivolts or 0.45, but it's always showing lower. So in that 15 and a half AFR range, we're actually showing down into the 200 millivolt range. So that's going to fool the computer into thinking, hey, we're running lean, we need to richen up, and we need it to swing higher than that. So what I want to do right now is I'm going to shut the car off. Let me go shut the car off. So what I'm going to do is I'm going to unplug the factory oxygen sensor. I'm going to take the connector that's going to the ECM, and I'm going to take this brown wire that I got right now on my voltmeter. I'm going to take this brown wire and I'm going to hook that to the ECM input, and I'm going to use this wideband with this output signal and tell the computer that's my oxygen sensor. And then we're going to see what happens. We're going to start the car back up, get it back into closed loop. And if everything works out right, I mean, we might have to tweak the scale a little bit, but the laptop then should be always swinging we're shooting for the low 14s. And if we can go into the low 14s with it, I think it's going to smooth out and run so much better, and might even have a little bit more pep to it. So let's get that going first. We're not going to drive it that way, obviously, with everything kind of hooked up, with alligator clips. But let's test it first, and if we get the number that we want out of the exhaust, then we could hardwire everything and then take the car for a ride. Okay, so we got it all hooked up. We have this purple wire here that is going to our wideband. Our wideband is giving out a signal, and that purple wire is going to the ECM. Right now we have it scaled. It took a little bit. We had to keep playing around with it. But we got it scaled now to where it's in the low 14s, high 13s is where it's trying to maintain. And this is at idle right now, closed loop. So if we rev it up, let's see what we get for giving a hold of the camera steady enough. To me, that's much better. wasn't fluctuating as bad. It wasn't, you know, the car is idling a lot smoother right now. It seems to like this air-fuel ratio. Idle speed is up. I think we're gonna hardwire it this way and take the car for a ride. All right, I got everything wired up to the stock ECU, and right now we've got it idling. It's doing its swing like it wants to do, but it's not going into the 15s anymore. We're hovering around the high 13s, low 14s. Now we're gonna go take it for a drive, and we'll see what we get while we're cruising with it. All right, we're cruising at 55 miles an hour, almost 60, and we're hovering right in that 14.0 range. I'm pretty happy with that. The car's running great. Do a little wide open throttle here. Plenty of fuel, a lot of that, or not a lot, but some of that is the water injection of methanol, richening it up. But yeah, I'm very happy with it. As we come to a stop here, let it idle. Yep, idle. Got some little acceleration here. Miles an hour, and here we go. Working good. I like it. Let's get it back home. All right, so little recap. We took and put a wideband oxygen sensor in the downpipe, and the reason we put it in the downpipe is that wideband O2 sensors, they don't like to be in a pressurized environment. So trying to put it in the up pipe where the factory oxygen sensor is, that up pipe's going to have back pressure under boost. The exhaust is going to stack up before the turbo, and there's going to be back pressure there, or pressure in that pipe. So we don't want to put it there. So that's why we have it in the down pipe. So put the wideband in there, took the programmer and adjusted a scale for an analog output to basically mimic a factory style narrowband oxygen sensor. Had to make some adjustments to that. Got it to read, and the reason we adjusted it was so that we could get the air fuel ratio that we wanted. We wanted it to run just a little bit richer, right in that 14.0 area. And we did that and wired everything into the factory ECU, took it for a ride, and it works the way it's supposed to. Computer doesn't know any different. Check engine light never came on. The car seems to run better. I think there's just a few benefits to it. Smoother idle, a better idle. The idle speed actually came up a little bit because we added a little bit more fuel. Driving the car, cruising with it, you don't feel it surging as it's swinging into a lean area from the factory O2 sensor. Feels like it has a little more throttle response. Just overall, it seems to be running better. And actually, it'd probably run a little bit cooler also, because when you're running really lean like that, you could tend to create a little extra heat in the engine. But I think it's a great thing. The Innovate Motorsports LC2 wideband oxygen sensor and controller, it runs about $170. So a little bit on the pricey side if you're looking to do this, for not much of a performance benefit, but definitely a drivability benefit. Wide open throttle, there's no difference in performance. Wide open throttle, the computer's not even being used. Computer just basically goes into a predetermined amount of timing and just lets the computer go full rich and lets it go that way. It ignores the oxygen sensor anyway. So there was no gain on the wide open throttle side of things. But that's going to wrap it up for today, guys. Hope you enjoyed the video, and be sure to subscribe and like and ring the bell for notification for the next video. And we'll see you next time.